So in hyperbolic functions, I think this one is just a bit similar to your basic trigonometric integrals, but this time is you just have the hyperbolic terms. So again, as you can see here, formulas 1, 2, 7, 8, 9, and 10 are the familiar formulas from calculus 1. So these are the formulas that have its corresponding derivatives in calculus 1. So derivative of hyperbolic cosine is this one. So it's the reverse of everything, diba, in the derivatives. So for the formulas 3 to 6, so you can just integrate this one as we go along the process. So just like the other examples that we have mentioned in the trigonometric integral. So for example, your hyperbolic tangent is this one. The answer is this one, ln of hyperbolic cosine. So it's because that we have broken it down into its components like this one. And then we use the U sub technique. That's why the appearance is more likely a logarithmic integral. Katong du all over u. Diba? So it became ln u plus c. So more likely formulas 3 and 4 is being derived in this manner. Okay? Then for the secant and cosecant hyperbolic na functions, so more likely they will be used in other techniques, but still, yeah, so this one is one format of the hyperbolic secant. I think there's another format for this one if you have to use the basic formulas. But as you can see, this one is a hyperbolic tangent, arc sine, di ba? Arc tangent hyperbolic. Okay, so for you not to be able to murag kapoy siya i-pronounce, di ba? Hyperbolic sine, hyperbolic cosine. So you can incorporate the H in the pronunciation of the different functions. So instead of hyperbolic sine, so you can pronounce it as shine. Well, it's easier, shine. Then this one is cosine, di ba? Cosine. This one is tangent. Kuha lang ang H, tangent. Di ba? Kaya secant, cosecant, di ba? Para mas dali siya i-pronounce. So of course, this is not a proper way of pronouncing the hyperbolic terms, but since magdali man ta usually in problem solving, so it's better that we have some shortcuts. But of course, if someone asks you how to pronounce it properly, so kibaw mo saan pag-pronounce, di ba? Hyperbolic sine, hyperbolic cosine, hyperbolic tangent. Okay? So let's go to, so of course I'm going to include the integral of the exponential functions. So the integral of EU du is just EU plus c. Diba? So in their derivatives, so derivative of e to the power of u is EU du. Diba? Murag same ras lang, no? Murag bali-bali rin siya. And then if you have the exponential functions with a number as its base, so a being the constant. So again, this one is having a constant of okay, so katong inyong kuan is pwede siya katong ano na nag-chat ha. So unsa ni pasabot ni mga arc sine and arc cosine? Okay, so sige, later lang na. So A is the constant. So again, exponential functions, of course, terms having exponents. So there are times that your base is not a variable. So it could be this one, diba? Your base is an exponent. I mean, is a numerical value. So let's say 3 to the power of u, 3 to the power of 3x. That's yan ang examples. So its corresponding integral is this one. 8 to the power of u all over ln a plus c. Okay, so au all over ln a. So again, if you try to derive this one, so more likely you'll be using katong, what's the particular term, katong um, u dv minus v du all over v squared. Ay, kalimut ko sa term man eh. Masama na siya yung gamiton, di ba? I think it's v du minus u dv. Magbali man siguro, no? Masama na siya. And the other one is, I think that's the chain rule, u dv plus v du. I think this one is reversed. Marag kani siya is v du all over u dv over v squared. If you have difference of two terms, I mean the quotient of two terms. So product of two terms is muna siya ang iyang derivative, di ba? So let's say u times v. Okay, so that's for your exponential functions. Oops, sorry. So let's go to the 6 examples that we need to discuss. Okay, so starting with the first one, so we have hyperbolic sine x, hyperbolic cosine squared x dx. So again, don't make your lives complicated. So this one is just an easy problem. So more likely is we're going to have, since this one is squared, diba? And also we have sine dx. So we can just use the u sub technique. So let u be the hyperbolic cosine. Then the derivative of your hyperbolic cosine is just a positive sign, diba? Because there's no negative in hyperbolic sine and cosine a derivative. So both are positive values. Okay, so as you can see, we can now simplify our answers into u squared, then du. Then you have u cubed all over 3 plus c. So again, don't forget to replace the value of u again. So you have hyperbolic cosine cube or cosine cube x all over 3 plus c. So this is the final answer. Okay, so I think what's best here in your hyperbolic functions is more likely the examples that will be, or the items that will be presented in the exam for the hyperbolic functions are just simple compared to the trig functions, wherein you need to be dealing with different identities and equations or other simplification process just to get a simple version of that particular function. So I think that's the best part of hyperbolic. So the problems are a bit easy. Okay, so tangent squared x, hyperbolic tangent squared x. Okay, so of course, the same as your trigonometric functions, Pythagorean identities. So this one also have its corresponding Pythagorean identity. So hyperbolic tangent. So of course you can just have your secant squared, secant, secant siya, secant. Okay, so this one is minus 1 dx. So correct me if I'm wrong. So I think this one is a correct answer. So let's try to okay, so I think that's a correct answer. The addition correct there. So negative kung ano siya. So hyperbolic identities is 1 minus tangent h squared is equal to secant na. So kung ano siya. So this one should be, so let's try to correct it. So sayo po kung memory there. So to be able to replace this one is we're going to have 1, sakto ba 1 minus secant squared x dx. Okay. So we all know that the integral of hyperbolic secant is just tangent, di ba? So the final answer is x minus tangent x plus c. So mubura siyang answer, ba? So I think you can just search for hyperbolic identities, and I think there are only a few equations for this type of functions compared with the trigonometric identities nga daghan kayo, di ba, katong negative quotient identities, product to sum to product, half angle. So murag daghan kay siya compared with hyperbolic identities nga gamay ra kayo. Okay, so I think if you have also mastered the hyperbolic function, so na siya mga corresponding kuansad kanang counterpart sa yung exponential version kanang, for example, we have, so if I may recall, I think this one is also an identity. So I think murag pwede siya mahimong e to the x minus e to the x all over 2 na minus e to the negative x there na. I think moment siguro na siya. So just try researching it online kay usually man good sa kaninga part since sa way back before before the new curriculum. So since trig has been offered in the course sa first year, so more likely once they reach the kaning calculus nga part, so they have already mastered or they already knew something about the hyperbolic functions. So muna siya. Okay. Okay, so next is we have an exponential function. So notice that this one is the base of the exponent is a numerical value. So meaning we have an integral of a to the power of u du. Okay. So again, just like the format, so we need to follow the format. So again, a is 3, u is x squared minus 4. Okay, so this one is already declared, this one is already declared. So what is left is to declare du. So derivative of u, so du is 2x dx. Diba? So take note that this one is the u parameter and this one is x dx. So take note that we have x dx here. So we divide by 2. So we have x dx. So notice that everything can be replaced in the equation. Okay, so you have a to the power of u, and our du is du all over 2. So taking 1/2 outside the equation, so you have a to the power of u du. So again, by formula, so again, don't forget to multiply 1/2. So again, by formula, the formula is a to the power of u all over ln of a plus c. Diba? So muna siya ang formula ang state in the previous slides. Okay, so bringing back the value of your a and u parameters, so you now have 1/2 times 3 to the power of x squared minus 4 all over, so ln a, so that's ln of 3, okay, plus c. So multiplying is we have 3 to the power of x squared minus 4 all over 2 ln 3 plus c. So you don't have to really get the numerical value of the denominator. So pwede na siya na. Or if you want another version of the answer, so you, di ba, ang kaning coefficient sa log functions is the exponent of the term here, di ba? So pwede sa ninyo ayan ay answer 3x sorry. So it could also be presented in this manner. So 3x squared minus 4 all over ln 3 squared plus c. So of course that is not the final answer because it's not simplified. So the final answer is this one, ln 9 plus c. So it could be this answer also. But kani is madawat to ani. So I'm fine with the coefficient of the log functions. Of the log functions. Okay, so do you have questions? So I think there's no question. So let's move on to the fourth example. So this time is we have the integral of a to the power of tangent t all over cosine squared t dt. So questions? Na question? Wala ra. Napilitan na siguro ang microphone. Okay, so again, this format is the format of a to the power of u du. So of course, as you can see here, a is still a. A is still a. The u exponent, so the u exponent is tangent t. Okay, so the u exponent is tangent t. Okay, so we have a dt here. We have dt all over cosine squared t. So notice that the derivative of your tangent is secant t squared dt. Diba? And then if you observe even further, secant can be declared as 1 all over cosine. So that's dt all over cosine squared t. So notice that this term here is this one here. So this one is du. Okay, so we can replace now. So we now have a to the power of u du. So ni simple na siya, di ba? So as long as you just follow the format, so it will always lead you to the final answer. So that's a to the power of u all over ln a plus c. So final answer is a to the power of tangent t all over ln a plus c. Okay, so questions? Okay, so I think there's none. So let's proceed to the fifth example. So this time is we have the exponential na atong e. So we need to follow this format. So e to the power of u du. Okay, so of course e is still e. So our u exponent here is, so let's try to remove 6 first outside the equation. So 6 integral of e to the power of 1 over x all over x squared dx. Okay. Okay, so of course, what's next to do is you declare the u variable, then get the du. So here is our u parameter is 1 over x. 1 all over x. So getting the derivative, so du is equal to, so again, this can be declared as x to the power of negative 1. So this one is negative 1 times x to the power of negative 2. Ba? N times n times x to the power of n minus 1. So bring down the exponent, then minus 1's exponent, so that's negative 1 x to the power of negative 2. So dx. So you have negative x to the power of negative 2 dx. So bringing back the value in the denominator, so you have negative dx all over x squared. So take note that this one is dx all over x squared. But yeah, sa atong derivative is we have negative sign. So divide everything by negative 1. So negative du is equal to dx all over x squared. Okay, so this term here is this one. Okay, so now is we have the u parameter. So 6 integral of e to the power of u. Then our du is negative du. So taking the negative sign outside, so negative 6 integral of e to the power of u du. So integral of eu du again is just eu plus c. So negative 6 e to the power of u plus c. So again, bringing back the value of your u parameter, so that's negative 6 e raised to 1 over x plus c. Okay, so that's the final answer. So questions? Okay, so if you don't have questions, so let's move to the next example. So this one is a final example. So again, we have the integral of e raised to sine x cosine x is equal to times cosine 2x dx. So again, this is a problem of the exponential function. So e to the power of u du. Okay. So our u parameter here is really obvious because this one is the exponent of the exponential function. So our u here is sine x cosine x. So notice that the partner of or the remaining term is cosine 2x dx. So it's a double angle cosine. So how we're going to achieve double cosine 2x with dx? So of course we don't know yet what really the outcome is. So let's try to derive this one first. So du is equal to, so again that's multiplication of two different terms. So let's say this one is u, this one is v, di ba? U dv plus v du. So sine x, di ba? Then derivative of cosine is negative sine x plus v du. So v, that's cosine x. Then du, the derivative of your sine function is cosine. So cosine x. Sakto? Okay, so what's next? So next is we have negative sine squared x plus cosine squared x. So by rearranging, so that the negative sign is on the second term, so we have cosine squared x minus sine squared x. So if you're not familiar with this particular format, so this one is the double cosine, double angle for the cosine. So if you try to search that one in your sa inyong mga phones karon ana, so this one is equivalent to double cosine angle nga na. This one is equivalent to cosine 2x. So other format for cosine 2x is, of course, we have 2 cosine squared x minus 1. And then the other one is 1 minus 2 sine squared x. So, of course, kanis lang format diri nga sa right side is just coming from this format because you just replaced the, so let's say you have cosine squared x minus sine squared x, then you replace this one with katong iyang corresponding Pythagorean identity. So cosine squared equals minus, so for the sine squared that's 1 minus cosine squared x na. So may mo siyang 2 cosine squared x minus 1 ana. Marag i-replace na siya with the Pythagorean equation. So that's why you have another format for the double angle cosine. Okay, so again, this can be declared as a double angle. So this one is cosine 2x dx. Okay, and this one is in the theta. Okay, so of course the output of your u sub is a simple equation. And again, since the integral of EU is just EU again, so we have EU plus C. Then we have e to the power of sine x cosine x plus C. Okay, so that's the final answer. So I think the problem here is most likely in the trig functions because there are problems that can still be incorporated with the exponential functions. So the trig functions can be incorporated in the exponential functions. So muna siya inyong dilemma siguro in the later part. So again, since what I have presented you lately are just the basics of the transcendental functions, so if you have questions like what if it doesn't follow the format, what if bisag unsaon og kana u sub or a sub technique is you cannot really get the answer. So that will be for the next topic, which is the advanced techniques. Okay, so do you have more questions or clarifications? Okay, so I think there's no question on my question.